Transitioning Assembly Line by Jonathan Shockley, Caleb Bushford, and Sierra Guerrero. Line layout and assumptions. The first assumption is 100% of units built are acceptable, meaning there's no rework. Second assumption is workers work 8 hours in a shift and the company runs 1 shift a day. The total length of the assembly line is 48 feet. And each workstation is 6 feet long. There are 22 working days in a month, and the assembly requirements are 22 a month for product A and 55 for product B. Straight line assembly pros and cons. So the pros over on the left are production rate, easy access from both sides of the production line, mass production, and operator training. The cons over on the right are the production line may become a barrier, supervision, wasted time, very high equipment cost, inflexibility, large deviation in product rates. The long line may not coincide with the size of the space given, repetitive injuries, pace set by the slowest operator. U-shaped assembly line pros and cons. So the pros over on the left are product variety, flexibility, cost, motivation, supervision, walking distance, and allocation of tasks. The cons over on the right are refilling material, not as easy, and operating training. Facility footprint. Implementing a U-shaped assembly line will reduce the overall footprint and benefit in the following ways. Material movement. A more compact cell means material does not have to travel as far from station to station. Moving on to the next bullet point, we have facility utilities. So an assembly line that is smaller requires less energy to heat, cool, and light. Because there's less heating, cooling, and lighting equipment, this means the maintenance on all the equipment will be less. On to space management. The facilities have limited floor space, so compacting an assembly process frees up space for other things within the facility. And the last bullet point is facility upkeep. The smaller production process will also allow for a smaller facility, which requires less upkeep and building costs. A smaller building also is easier to insulate and light.
Key variables, issues, and risk. Layout design product A, improved design function, increased efficiency to 200% than a straight line for product A. Issues of unequal distribution between the operator and the machine. The risk of influencing the change for product A was reducing at 9 hours per unit to below 8 hours. Product A has 4 workers, while this one has a start of 7 workers on the second day. And the layout design for product B increased efficiency for first group 237% and 178% for second group than a straight line for product B. And 4 of those workers will break off when moving to D and E, called first group. An extra worker will have to wait 45 minutes before joining the 2 workers on A, B, and C, working to form second group. And the way the 4 workers will produce 3 units, while 3 workers will produce 2 units, with each equals 5 units when completed for the day. And there are issues of unequal distribution between the operator and the machine. The risk being an already 2.5 output has to be doubled input.
Conclusion. The implementation of a U-shaped layout over that of a straight line will result in an improved efficiency and savings. Parts will be made more efficiently, requiring less time to make and therefore less cost overall. The footprint of the facility and assembly line will be reduced, which will result in a facility maintenance and utility costs being reduced. Making parts faster will result in less employees needed to make the part, and therefore less paid hours.